Hello, and welcome to this presentation, Understanding Remote Instrument Access. In this short presentation, we'll provide a brief introduction to the different methods you can use to remotely access or control Rohde Schwarz test and measurement instruments. We'll start by explaining the three most common types of remote access. The first of these is remotely viewing the GUI. In other words, we simply see what's currently on the instrument's GUI, but don't actually operate the instrument or change anything on the instrument. In many cases, however, we do want to interact with the instrument by changing settings, starting and stopping tests, etc. This remote GUI control is what most people mean when they refer to remote access. For example, we might use a remote GUI to change the center or span on a spectrum analyzer and then see the results of the changed settings. The third type of remote access is programmatic control. This is a fancy way of saying that we control the instrument by sending it text-based commands, and we receive information from the instrument in the form of text-based replies. In most cases, test and measurement instruments from Rohde & Schwarz support both remote GUI control as well as programmatic control, either separately or simultaneously. The other important topic in remote access is the connection method. In the past, GPIB, based on the IEEE 488 standard, was one of the more common ways of remotely controlling or communicating with test and measurement instruments. There are, however, a number of issues with using GPIB for remote access. First, there's a maximum cable distance of about 15 to 20 meters, and there's also a limited number of devices that can be placed on a GPIB bus. Because GPIB is primarily intended for programmatic control, it's relatively low speed and generally doesn't support true remote GUI access. That said, an Ethernet interface is now standard on most modern test and measurement instruments. Ethernet is well understood, low cost, and high speed, especially compared to GPIB. And since connectivity is almost always IP-based, there are no distance limitations. As long as the instrument is reachable via IP, it can be remotely accessed or controlled from anywhere in the world. Some instruments may also support local connectivity over a USB or Wi-Fi interface as well. There are four main methods for remote GUI viewing or remote GUI control of test and measurement instruments. These are remote desktop, VNC, web browsers, and dedicated applications. Let's take a look at each one of these methods in a bit more detail. The Remote Desktop Protocol, or RDP, was developed by Microsoft as a means of remotely accessing Windows machines, so RDP is primarily used for instruments which have a Windows-based user interface. The standard RDP client included with most versions of Windows, Remote Desktop Connection, provides interactive GUI viewing and control of the remote instrument. There are also clients available for Mac OS and Unix/Linux, for example the RDesktop client. VNC is very similar to Remote Desktop in that it provides remote GUI viewing and control. But unlike RDP, VNC allows multiple users to access a GUI simultaneously. VNC is open source, and there are many clients and servers available for different operating systems. In particular, VNC is often used for remotely accessing instruments that do not have a Windows-based interface. Most test and measurement instruments have buttons or keys on the front panel for performing common tasks, such as setting frequency and level, saving and recalling information, or presetting the instrument, that is, returning the instrument to its default state. Therefore, many remote GUIs will have a way of emulating the more common front panel buttons. This allows the instrument to be used in much the same way, both locally and remotely. Both Remote Desktop and VNC require some type of client software. In many cases, however, a standard web browser can also be used to access and control test and measurement instruments, meaning that no additional client software needs to be installed or configured. In most cases, we simply enter the instrument's IP address and then select Web Control to enable the remote GUI. In addition to an interactive remote GUI, web-based access also offers additional functions and features for controlling and configuring the instrument remotely. Many test and measurement instruments have a Windows or Unix/Linux-based user interface, and therefore can be accessed via standard remote access clients, such as Remote Desktop or VNC, or via standard methods, such as over a web browser. On the other hand, some instruments, especially those not using Windows or Linux for their user interface, may require a special or dedicated software application for remote access. In the case of Rohde Schwarz instruments, these can be easily downloaded from the Rohde Schwarz website. In most cases, these dedicated remote control applications provide the same kind of remote GUI control that's available with standard remote access methods. Although remote GUI control is very popular, instruments can also perform actions and return results using text-based commands. For example, instead of using the GUI on a spectrum analyzer to run an occupied bandwidth measurement, a client could configure a spectrum analyzer by sending it a series of commands. Additional commands would be used to start the measurement and query the result. On the client side, the commands themselves can be sent and received in many different ways. For example, using programming languages like Python, Visual Basic, C++, MATLAB, etc. Programmatic control is particularly useful in the case of well-defined test scenarios or repetitive tests. Programmatic control also allows for fully automated testing and can configure and execute tests much more quickly than would be possible either using a local or remote GUI. In some cases, programmatic control may be used together with a GUI, for example, when developing test scenarios or when visually monitoring test progress or results. Almost all programmatic control is based on the so-called SCPI standard. SCPI stands for Standard Commands for Programmable Instruments and defines common methods and syntax for instrument control. SCPI was originally defined for the GPIB interface, but is now used over other physical interfaces such as Ethernet. The general format of SCPI commands are text strings consisting of a keyword followed by one or more parameters. For example, if we wanted to set the center frequency of a spectrum analyzer to 800 MHz, we would send the text string freq_cent 800 MHz. If we wanted to retrieve the current value of the center frequency, we would send the text string freq_cent?. These are the SCPI commands that would be used to perform the occupied bandwidth measurement mentioned on the previous slide. Almost all Rohde Schwarz instruments support programmatic control or test automation based on SCPI, and each instrument's user manual contains a complete description of the supported commands and numerous programming examples. Let's summarize what we've covered. Remote access most often refers to methods used to view and/or control an instrument without physical access to the instrument itself, for example, when working off-site, or when collaborating with geographically distributed coworkers. The most common methods for remote GUI access on Rohde Schwarz instruments include the Remote Desktop Protocol, VNC, web browsers, and/or dedicated remote access applications. In addition to remotely viewing or accessing the instrument's graphical user interface, most instruments also support programmatic control via text-based commands. These command sets are normally based on the SCPI standard and are typically used for well-defined or automated testing, as well as in cases where high speed is required. Most Rohde Schwarz instruments support more than one remote access method, so please refer to the accompanying documentation or contact Rohde Schwarz if you'd like to learn more or need help getting started. This concludes our presentation, Understanding Remote Instrument Access. Thanks for watching.